you can trivially move from computing locally to computing on AceCloud with that. But also, there's a command line mode for using it, which I'm going to demonstrate first because I think it gives if you're not familiar with running work in an asynchronous, in a batch mode, can I actually show of hands? Is anybody familiar with using an HPC cluster in an academic context? So, okay, most of you. So then you're familiar with running with a batch system and queue subbing and queue statting and so forth. The interface that we have at the command line is similar to that, so it will give you a good idea about how it works. So this should look familiar. This is what Gianni showed a moment ago, a run directory prepared for an ACEMD simulation with the input files you'd expect to see. If one wants to run this on AWS, then the command is simply the AceCloud client, a command line client, with an argument submit to say run the job, and then the location of the input files which are going to form the job which gets run. This here is an identifier for the job, which you can use to keep your accounting, your bookkeeping up to date, so you know which simulations are which. Behind the scenes, this client does everything required to copy the data to Amazon's cloud and to start up some compute resources which have a GPU, run an operating system image which has ACEMD, and start the simulation. And all of that happens behind the scenes without you having to have any direct interaction with AWS. All you get is, or have to deal with, is a view of the activity that you currently have on AceCloud. So analogous to a QStat listing, you can see the activities that you have, the simulations that you have running on AceCloud. The salient things to note here is that we, rather than having the system give you an identifier and then you have to remember that job 473216 is this bit of work, you can use your own naming identifier to describe your activity. We have a sort of two-level hierarchy of identifier because this is a tool which is really designed to facilitate running high-throughput MD, so large numbers of independent simulations in Ensemble, but it still makes sense to consider those simulations as part of a logical group. So we have a group identifier which allows you to manipulate a whole set of simulations in a collective operation. For example, you can retrieve all of the results of a group or just the results of one of a simulation, depending on how you refer to it. This view is always live as well, so you'll always get an up-to-date status, an idea of how your work is progressing. One of the things that is a consequence of the fact that you're running on a remote resource is that you don't automatically get the output of your jobs coming back to your local workstation. So you have to run this command, retrieve, which does that for you, which goes to Amazon, gets the results of your simulations. What that means is it will take partial results. If you have a simulation in progress, it will get the state to date. If a simulation is finished, then it will get all of the results. And it puts those back in the directory where the job was originally created from. So the end result is the same state as if that job had run locally on your workstation. Finally, if you need to delete jobs or tidy up after your jobs are complete, then you use the delete operation. I show this because this gives you an indication of how you can use these collective operations. The group might have hundreds of simulations in it, but this one operation is enough to operate on them all. And once a simulation or a run is deleted, then there's no ongoing use of Amazon resources there, so you're really only incurring a cost or using Amazon resources when you start the job to the point at which it's completed and you've deleted the results. So moving slightly higher up and looking at how you might, rather than interact with AceCloud directly, just use it as a way of improving the throughput of your MD in an HTMD workflow. Here is a use of the equilibration protocol, which Johnny showed just a moment ago. And he showed you this, the local GPU queue, which is what we use to abstract the running of ACEMD on your local machine. Well, suppose this isn't equilibration but production, and you have a large amount of work to run. You can simply swap this out for AceCloud queue, and exactly the same simulation will be performed, except it will run on AceCloud rather than have to wait for a GPU to become free on your own machine. For fairness, I should also say that suppose you have access to an HPC cluster, you might have PBSQ or LSFQ here in order to submit the work to that. That, of course, requires some configuration because you have to understand the peculiarities of the configuration of your local cluster, whereas AceCloud, because it's much more controlled, is something which just works. Likewise, in the special case of run parameterization, which I'll talk about in the next session, the parameterization tool has a command line client, which is the preferred way of interacting with it. Without saying too much about it now, a large number of quantum chemistry calculations have to be performed. All those calculations are independent, so they're a good candidate for parallelization across multiple resources. If you have a cluster, then you can submit all of those jobs to your cluster. If you have AceCloud, then you can run them that way. And the way you select where the jobs are going to run is just as simple as with a command line flag to say, run the jobs on the cluster, run the jobs on AceCloud.
Where does it get the default for LSF, for instance, in this situation?
The default?
Like the queue name inside LSF, or
so we have sensible defaults in the queue system. If you have a peculiarity of your setup that means the default won't work, at the moment it requires a little bit of additional work on your part to make that go. I should say, for industrial customers, that's the sort of integration that we do as a value add. So if you have HTMD installed already, then the AceCloud client has come along with that installation. You can also install it independently, through Conda, which is the channel we have for distributing all of our software now if we can. And we support all three operating systems. For the moment, I'll talk about the configuration of it first. So the first time you install it, you have to go through a little bit of configuration work in order to integrate it with your Amazon account. This takes a little bit of time, but it's reasonably straightforward. There are two main steps. The first one that you have to do is to install a virtual machine, to get access to a virtual machine image, which is the software which is going to run on the Amazon side of the system, and that's the operating system image that contains ACEMD and the rest of the software that you might use. And then the second thing is to get access to some access credentials, which are like a username and password, which you'll use, the software will use on your behalf to talk to Amazon on your behalf and federate, orchestrate the creation and destruction of resources. So to do those two steps, you need to run AceCloud setup, and that will take you first to this website. Normally, if you run this on the command line, it will open a web browser. This is the Amazon marketplace. At this point, you have to subscribe to our product. Normally, this says click to subscribe, but it's a view of my account and I've already subscribed. The next step is to get the access tokens, and again, the software will direct you to this web page on Amazon where you simply click create new access to and copy the credentials back into the client, and then it's configured. If you don't have an Amazon web services account, then the first time you visit this, it will take you through the account creation process, which takes a little while. Now, there is a running cost associated with AceCloud because Amazon is a business after all. And as I said back at the beginning, one of the things that this software does is try to use Amazon as cheaply as possible. So the default behavior is to use Amazon in